Hey there. Today I wanted to talk about generics, but then I realized when I was researching generics that you really need to talk about enum subscripts and protocols first. So we're going to do a tutorial on enum subscripts and protocols. An enum is the way that you create a group of related values. The typical example is maybe the suits in a deck of cards. So in the deck of cards you have clubs, hearts, diamonds, and spades. And enums in Swift are more flexible than the enums that you're familiar with from C or Objective-C. Or if you're not familiar with either of them, you'll be fine here. So enum, sum, enum, and then the enum goes here. So you can see it's very similar to the way you just made a class, the way you made a struct. Here's an enum of the points of a compass. So we'll call this compass points. And you always want to do it singular. I know I just said compass points, but you want to do it singular. So you'll do case north. You'll do case south, east, west. Now you have something that is of type compass point. You can say dot east, and that will be the enum value. You can see it doesn't exactly print out a string or anything. And if you look at this, it's going to be an enum value also. Here's an enum of the states of matter. You have case solid, case liquid, case gas. Now you have multiple members that you can also do on the same line. So if you wanted to declare this enum this way, which is kind of a shorthand, it may be easier for you. I like to put spaces after commas. Enums should be singular names so that they read as self-evident. So if we were going to go back to the compass one, you could say var direction to head. You could say compass point dot west, so that you could say the direction that you should head would be compass point dot west. If you did compass points, it doesn't necessarily make sense. If you already have set the type of the direction to head, then you can drop the type when you're writing this. So what you can do is you can say direction to head is equal to a compass point. It's of type compass point. So now you can write direction to head is equal to dot west. And you can see that you just have to do dot west instead of compass point dot west. If you want to figure out which enum value is set, then you use a switch statement. So we have our matter here. So if we say var current matter is equal to, let's say, is equal to matter dot liquid. And somehow that was set dynamically. Now we want to figure out which one it is. So we say switch current matter. And then we're going to say, is it solid? And then we can do a print line and say, it was solid. And of course it's going to give us an error until we make this all inclusive, or until we write a default statement, liquid, or is it gas? And here we would write liquid so that we have the right message, and gas. So there you could see in the console log that it was liquid. So that's how you figure out which was which. So again, the switch statement must be exhaustive. And you can also have enums with associated values. So sometimes you want to store some value of another type, not just the enum type, with the members, and the liquid, gas, those are the members. So if we were to get rid of all of this, and we were to make an enum that is called computer, and we were to say case desktop, so it's like which kind of computer would it be? And with that, we're going to store an int and a string, which maybe would be the RAM and what type of processor it would be. And if it were a laptop, then we would store an int, which maybe would be the screen size, because that's maybe most important for the laptop. And then if it's a phone, we might store the weight. For a case phone, maybe we'll do the weight and the height and width. And then if it's a tablet, maybe we'll just do the width and the height, case tablet. So here's an enum called computer. Maybe it wouldn't be called computer, maybe it would be called technology or something, I don't know. But computer is the best I could think of for right now. So you're going to make a var called computer, and you're going to say it's equal to computer.desktop, and you want to store the int in there. So the RAM it has, let's say, is 8 gigabytes of RAM, and the processor is an i7 processor. Now you can do the same switch statement, but we'll also be able to pull the associated values. So we can say switch computer. You can say, in the case of a .desktop, because it already knows the computer is going to be of type computer, so we just want to get the associated values. That's why we can do .desktop. So here we can type let RAM, let processor, and then underneath we can do a print line and say was a desktop. Just for the heck of this, we won't write all the statements. We'll do a default, and we'll just do a print line. No idea. So we'll say it was a desktop, and then from there we can get the RAM that's associated with it. So we'll say it was a desktop with 8 gigabytes of RAM and a processor. So then what we'll see is was a desktop with 8 gigabytes of RAM and an i7 processor, and then you would change that statement based on which one that you selected. So you can do the let for each one of these to declare the temporary constant, or you can just do one gigantic let statement, and you can put that here. You can say let desktop, and then you can write RAM, and you can write processor. It's the same thing, except you only have to write let once, and then those constants get passed into the statement below. So that's obviously a shorthand there. You can also have a raw value. Now a raw value is different than an associated value. Raw values, they have to be unique within the enum. The associated values are something that you're going to use to get information out of the enum. The raw values are more like unique identifiers. If they're assigned as ints, and I'll show you this in a second, then they will auto increment if no other values are provided. And this is actually kind of neat. Let's make an enum called planet, and we're going to declare the raw value to be an int. So that's what you do right after the word planet. You're going to say the raw values for this is going to be an int. So the case Mercury is going to be equal to 1. And now if we don't tell what Venus is, or Earth, or Mars, because remember you can define these in comma separated like this. Jupiter is with an E, Saturn, Uranus, or however you say that, Neptune. There's a way that you can get the raw value out of these. Now this is the first time we're dealing with raw values, so I didn't show you this before, but if we were to say planet.earth.toRaw, you can see that it says 3 here, because Mercury is 1, Venus is 2, Earth is 3, because it's giving that an automatic raw value that's going to be auto-incrementing, because that's the way that it works when you use integers. Now you could use strings, you could use something else. It just has to be unique. That's the most important part. And you can also say planet.fromRaw, and then you have to pass an int because the raw values are ints for planets. And let's say we did 5, and that gives you an enum value. And that's not just going to print out Jupiter, because Jupiter is not a string. Jupiter is an enum value. But what you can do is you can then do a switch case statement, or you could just do an equals equals, and you could say, is that equal to planet.Jupiter? And it's going to say, yes, it is. Is it equal to planet.Mars? No, it's not. From raw is going to give you an optional of type planet, because from raw, if you typed in here 100, well then from raw is going to be nil, because there is no raw value 100, but there is a raw value 5. So you're getting a optional of a type planet. You could define it like this. You could say var this planet is of type planet question mark is equal to that, and that's giving you an optional planet. And an optional planet didn't exist before this point, you just created it. So you can use the optional bindings to find the planet with the raw value. Remember this from the first tutorial. If let possible planet is equal to planet dot from raw 5, and then you could do a switch case there, and you could say switch possible planet, because that temporary constant is getting passed in, and then you could do case Jupiter. Print line was Jupiter. and then we could just do a default for now. Otherwise, you could list all the planets. You could say, I do not know. So we know it was Jupiter. And then what you could do is you could do an else, and you could say print line, just like we did from the first tutorial, no planet found here. So you could see it was Jupiter, but if we change this from raw to 100, no planet found here. So that's how you can check the enums. So that's all I'm going to say about enums for right now. There's so much more you can do with them. You can have functions going on in enums, but that's enough enums for now. We're going to actually run into some more enums in a second when we talk about generics and protocols. Thanks for watching. Next up is going to be subscripts, and I think you're really going to like that. Then we'll do protocols, and then we'll get to generics. The next few tutorials until generics are going to be quicker tutorials. Thanks for watching. And don't forget to subscribe to us on YouTube and on Twitter and Google Plus and Facebook and everything else there is to subscribe on.